Okay, so this is section 2.5 of Unit 2. This is the last section. Here are the online examples. So first we'll look at the exponent law. This law is the law for a power of powers. So to raise a power to a power, all we have to do is multiply the exponents. So this means if we have any integer a, so letting a, the variable, represent any number except for 0, raised to the power of m, and then raise that power to the power of n, all we do is multiply the exponents. So that would equal a to the m times n. So let's look at a quick example here. 2 to the power of 2, all to the power of 3. This equals, if we expand, 2 to the power of 2, multiplied by 2 to the power of 2, multiplied by 2 to the power of 2. This gives us 2 times 2, multiplied by 2 times 2, multiplied by 2 times 2. This gives us 2 to the power of 6, or 64. Now, as you can see, 2 to the power of 6 can be also written as 2 to the power of 2 times 3, because 2 times 3 equals 6. So let's look at another example. 3 to the power of 3, all to the power of 3. We can write this as 3 to the power of 3 multiplied by 3 to the power of 3, which equals 3 to the power of 9, which equals 3 times 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 3, which gives us 19,683. Next exponent law. Exponent law for power of product. So a and b are any integers except for 0. This means that a and b are any number. They can be any number, but they cannot be 0. And m is any whole number. So that means it's not a fractional number, which means it can be -1, 1, 2, 3, 0, 7, 47, but nothing like 1/2, 3/4, or anything like that. So, as it shows here under the title, a times b to the power of m is equal to a to the power of m times b to the power of m. So, let's put that into an example. 2 times 3 to the power of 2 is equal to 2 times 3 multiplied by 2 times 3. But we know that because this is repeat multiplication, we do not need the brackets. So we can have 2 times 3 times 2 times 3. We also know that when we are doing multiplication, order does not matter. So we can rearrange this as 2 times 2 times 3 times 3. But this can be rewritten as 2 squared times 3 squared, which equals 4 times 9, which equals 36. So as you can see, we just multiply both of the base numbers with the exponent. So let's look at another example. 3 times 4, all cubed, is equal to 3 cubed times 4 cubed. This is equal to 27 multiplied by 64, which is equal to 1,728. Exponent laws for a power of a quotient. So if we have any number a divided by any number b, except for 0, all to the power of n, and letting n be any whole number, again, no fractions, we just, again, factor in our exponent. So let's look at an example. 2 over 3 to the power of 5. That is equal to 2 over 3 times 2 over 3 times 2 over 3 times 2 over 3 times 2 over 3. But we know when we are multiplying fractions, we can write it as one full fraction and just multiply the numerators and multiply the denominators. That gives us 32 over 243. But we can also write that as 2 to the power of 5 over 3 to the power of 5. As you can see, all we did is we moved the 5 inside the brackets and applied it to the 2 and the 3. Let's look at another example. 2 over 4, all squared, is equal to 2 to the power of 2 divided by 4 to the power of 2, which equals 4 over 16, which equals 1/2. Now it's your turn. Try this one. Okay, so first step. We know that in order of operations, BEDMAS or PEDMAS, the brackets come first. So let's do the brackets. The operation inside the brackets happens to be division. We're only going to focus on the right bracket because it has the same base. Don't worry about the other bracket. I'll show you what to do in the next step. So, 2 to the 4 divided by 2 to the power of 2. We know that if we have the same base, we just subtract the exponents, which gives us 4 minus 2, which equals 2. So now we have 3 times 2 squared plus 2 squared to the power of 2. Now let's apply our exponent laws. We said if we have multiplication inside the brackets, we apply the 2 to both numbers. And we also said if we have a power to a power, we multiply the exponents. So we get 3 squared times 2 squared plus 2 to the power of 2 times 2. This means we have 3 squared times 2 squared plus 2 to the 4. Which equals 9 times 4 plus 16. And in order of operations, we know that multiplication becomes for addition. So 36 plus 16. Now finish off with your addition. Get the answer of 52.